Hi, I'm Don Mann with E+ Technology. We're a solutions provider for VMware, a national provider. We cover pretty much both coasts and Texas. Here today to talk to you about 10 gig and fiber channel over Ethernet, real-world design considerations, session TA8440. I talk a little fast, so hopefully you guys can keep up. Usually people say they can follow me, but I go a little quick. So the agenda we're going to go through today, I'm going to talk about the transition from 1 gig to 10 gig, talk about some of the advantages of 10 gig you'll see when you move towards that environment, focused on reduced infrastructure components and some of the performance and scalability improvements with 10 gig. And I'll do a brief cost comparison. I don't want to go into too much detail on it, but just to give you an idea where we're pricing out with 10 gig versus 1 gig designs. Then I'll talk about some design considerations, cover a little bit on fiber channel over Ethernet. I'll go over the various different hardware components we're going to talk about today, which is standard servers. Cover a little bit about HP Flex 10, actually FlexFabric, which is their new product launch as of a couple of weeks ago. Cisco UCS. And then I'll focus on a little bit of traffic shaping discussion as to what's changing in vSphere 4.1 and some of the increase in traffic patterns we're seeing. And lastly, I'll cover some specific design recommendations for all three of those scenarios, as well as specifics to the different vSwitch options in VMware. And if you guys have questions during the session, feel free to raise your hand, and I'll address those as quickly as possible. So starting off, 1 gig to 10 gig. Here's just really an image of what we're talking about when we talk about transitioning to 10 gig. This is a more traditional 1 gig configuration. Minimum config you'd see in 1 gig is basically 6 I/O ports, whether that's storage in an HBA world or with Ethernet. You're basically going to see 2 NICs, typically with vMotion and Service Console dedicated there, ideally prioritizing vMotion to one NIC and Service Console to the other, a dedicated NIC for your storage traffic, 2 NICs for storage, whether it's HBA or Ethernet storage, and then separately 2 vNICs for virtual machine traffic where we VLAN if necessary to isolate layer 2. In the 10 gig world, we're talking about basically 2 10 gigs bonded, 1 vSwitch, and port group sitting on top of that 10 gig. And we'll talk about some of the reasons why you might want to think about your design when going that route. Real quick, talking about simplifying the environment. Obviously, you guys probably are aware you've got a lot of cables coming out of a vSphere box in the 1 gig world. Minimum 6 to 8 links coming out. It's a lot of cables. And you move towards 10 gig, we're talking about reducing down to 2 cables from each server. In the bladed world, you can reduce that even further. If you're talking about 8 or 16 blades, you might have 2 or 4 cables leaving the environment depending upon your I/O requirements. And we've all seen the graphics. I don't want to stay too long on here, but the cabling's pretty ugly when you're doing rack-mounted servers with lots of cables coming out the back. This is a more traditional blade environment with 6 to 8 switches in the back. You end up still with a lot of cables. And then this is unified fabric. This could be Cisco. This could be HP. Anybody doing a unified fabric with fiber channel and 10 gig. Moving towards 10 gig, we're seeing a drastic reduction in the amount of cables in the environment. Important note here is a lot of people might think that you can just bond a bunch of 1 gig links together, but 10 1 gig links does not equal a 10 gig link. 1 gig links, essentially when you look at ether channeling, load balancing algorithms, not one session can go over more than one physical link at a time. So you cannot go beyond 1 gig for storage communications between an ESX host and a data store, for a client communications into the VM. It does not scale beyond 1 gig. Bonding links don't help you there. You're going to get a little bit of I/O balancing across the links. None of the balancing algorithms prior to 4.1 are actually looking at load on the NICs when they're doing the balancing. It's really just a round robin or a hashing table that's distributing across the links. But nothing's really looking at what the load is on those NICs. Sorry. Okay, so I actually took on this topic when 4.0 was out there. I submitted the call for papers thinking, holy crap, we can't just go to 10 gig. We've got to worry about traffic shaping. And then I actually looked into it. And it turns out with 4.0, the maximum speed for a vMotion was 2.6 gigabits per second for a single vMotion. And you were, at the time, I don't have this up here, limited to 2 vMotions at one time. So you could kick off 10 servers, and the maximum you'd see going at one time was 2. That equals about 5.2 gigabits per second. The reality is, after further testing, not all 10 gig links actually go 10 gig. So I'll mention that a little bit more later. But with 4.1, it's very important to understand that a single vMotion can actually do up to 8 gigabits of throughput. So a single vMotion kicking off can actually come close to saturating that link. And on a 10 gig NIC, VMware now supports and defaults to 8 sessions going at one time. So you can absolutely saturate a 10 gig link with vMotion. I'll tell you an interesting fact here. I was doing some testing on this when I was prepping these slides, and with JPerf, just generating load, I had 10 megabits of traffic going over the line. And kick off a vMotion, and you see it drop to almost 0. And spike and jitter and basically maintain near 0 with just 10 megabits on the line. So the important point here is this is important if you're moving towards 10 gig to know you need to do something. If you're going to kick off vMotion and you're on those same links as your virtual machines, you will see impact to those VMs. You'll see some jitter, some communications drop based off of vMotion if you don't do anything. And I've got some simple options for us here. So on 1 gig, they cap out at 4, and on 10 gig, they cap out at 8. And there is a benefit there. It makes vMotion quite a bit faster. I'm curious how many people in the room are leveraging fault tolerance today? Less than the last room. It was about 15% last time. That was probably about 5-10%. I don't see a ton of use of fault tolerance, but it's very important to understand fault tolerance because I do think it's going to pick up in usage in the future. Right now, they've addressed the VMXNet 3 limitation of fault tolerance. It wasn't supported as with 4.1. There is still the single CPU limitation that I'm looking for that to be addressed. But I think you'll see this pick up in the future, and the importance is to understand the traffic pattern of fault tolerance. So that is essentially you take your network communications from a VM from the clients to the virtual machine, as well as the storage traffic talking to the back-end disk, combine the two times plus 20%, and that's essentially what they anticipate the fault tolerance traffic to be for the VMs that you have that enabled for. So it can be a heavy utilization traffic pattern. More importantly, it is a very important and high criticality traffic pattern because it is synchronous communications. The traffic going to that secondary fault tolerance needs to write before it's committed. So you're not going to get a response unless that fault tolerance link is responding well as well. I had one more point on that, but if I remember, I'll go back to it. Brief cost comparison. I did list pricing on everything. And what I did is I priced out how many ports I was going to use on a switch. I divided by the amount of, I basically took the cost of the switch with everything I needed, divided the total by the cost per port, and I allocated that for, basically I did a 6-server comparison. So if I had 6 servers with 2 10-gig links, I took 12 ports as the cost of my Nexus. So you see here I priced out $49.48. I did a $49.48 with a $91.24. I tried to keep it low cost, low solution to make it at least fair. And then I did 10 gig on a Nexus 5010 Cisco switch, which I'm a big fan of. And you see it's not the cheapest solution out there, but it's relatively, fair in the same range, especially when you're looking at a fiber channel world. And then lastly, I started looking at cost per gigabit, and it's substantially cheaper. If you look at a standard 10 gig design, going 10 gig is the cheapest cost per gigabit that I could find based on list price. And then the difference in this cost here when you go with FCOE is there's a storage license on the Nexus 5010, so you have to license the capability to leverage fiber channel over Ethernet. So that adds cost to the switch itself, and it brings the price up quite a bit there. There are bundles, there are discounts. This is all list pricing. So I just want you to know it's not an astronomical pricing for moving towards a 10 gig environment. Not to mention the power savings and cost reduction, simplification of your environment moving there. I'm going to go over a few design considerations. I'm going to cover hardware just so everybody's got a base understanding of hardware. I'm not going to spend too much time on it, but the different scenarios we have. First one being standard servers and how those are going to cable up, what it looks like. Dive into a little bit of HPC 7000, focusing on their new FlexFabric, and I'll identify the difference between that and Flex 10. And lastly, I'll cover UCS briefly. And again, any questions, feel free to raise your hands. Sorry I started a little early for those of you still coming in. Standard server environment, not a real complex scenario here. You're talking about basically a redundant pair of Nexus 5010s, at least I hope, run a redundant pair of 10 gig switches. Your ESX host would have basically a 10 gig going to each of the two switches. You have choices of doing various VMware-based load balancing algorithms or enabling something like a VPC virtual port channel between the two switches. And you can bond these two links together as one, have basically a non-existent failover pattern when you actually lose a link versus the outbound virtual port ID, which has a very brief failover. And then one of the points I want to make here is if you've got storage and it's on Ethernet, you might consider 10 gig there as well. If you're going towards vSphere, why not give yourself that additional bandwidth? It's pretty low cost to add a NIC, or in some cases you might have to change your array, but most of them can upgrade to 10 gig fairly easily. The other important thing here is you do not have to upgrade your core. Core switches don't upgrade as often as top-of-rack switches or end-of-row. It's quite a bit more costly to upgrade your core. You might be going that route. I highly recommend considering something like a 7K if you are going 10 gig and you're looking at a core upgrade, but it's not required here at all. A lot of the communications occurring in a vSphere environment is local to the data center. It's storage to VMs, or it's vMotion occurring within the data center. We've done a lot of studies. I did Capacity Planner. I took a bunch of different customers we'd done. This is a VMware assessment tool. Stacked them all together. I did disk I/O to the back-end disk and VM traffic, which is basically the clients coming in, talking over the standard NICs. And it's about 6-to-1 more I/O throughput going to the back-end disk than it is coming from the outside world. The average traffic I saw coming from all your clients combined to a single virtual machine across 1,000 systems was 0.8 megabits per second. So very little I/O in most scenarios is actually coming from your outside clients coming into the environment. So a lot of the communications is happening on the back end inside the core, inside the data center. Not a lot of reason necessarily for just doing 10 gig to go upgrade your core for that purpose. One other important point here is when you are talking fiber channel and Ethernet, somebody brought this up as a question in the last time, this session prior, asking about how do you maintain fabric isolation when going with FCOE. So these two 5010s might be bonded with a VPC for Ethernet, But these are separate VLANs, so this might be VLAN 101 and VLAN 201. FCOE, I'll talk about in a little bit more detail, is writing over a VLAN, physical layer changing to an Ethernet cabling. But essentially, you'd have those two different VLANs, and these are separate fabrics. This is vSAN 101 and vSAN 201, and they're two separate fabrics maintained as separate fabrics. So very similar to what you're seeing today in a fiber channel world. Not a lot of differences there. Talking about HP C7000, just basically want to show the front. It's a 10 rack unit system. It can handle 8 to 16 blades. The 8 would be with full width blades, which are essentially 4 proc boxes with double the memory footprint. And then the half height boxes are 18 DIMMs with 2 procs. So basically what you see in a standard 1U, 2U, the full heights are usually in the range of the 4U boxes, rack mount servers. The importance here for today is talking about the back of this chassis. Those front servers basically come into the front, and out the back you've got 8 bays of interconnect modules. In a traditional design, when we first started with the C7000, in a VMware environment, we'd populate all 8 of these bays because we talked about needing 6 or 8 I/O ports. For a half-height blade, basically, you get 1 port out of each of these. So to do 6 1-gig Ethernet, I'd have to buy 6 Cisco or HP switches in here, and then if I wanted fiber channel, I'd buy 2 extra fiber channel switches. Now I'm sorry, question? In a newer feature of HP, they've announced Flex 10 and recently announced FlexFabric. And essentially what that is as of the HP G6 blades, they now have 10 gig onboard NICs that can downgrade to 1 gig if you choose, but they can support 10 gig. And you can then buy these Flex 10 or FlexFabric modules, just populate bays 1 and 2. Recently cost switches, they're in the range, list price, the Flex 10 is about $12.5, and the FlexFabric lists at $18.5. So you buy 2 switches here instead of buying 8, and then basically we can take 2 10 gig links and carve them up into what they call Flex NICs. So you can present yourself 4 Flex NICs per interconnect, totaling a total of 8, so you can still work that traditional design. And then the difference in Flex 10 and FlexFabric is they offer you an FCOE module, or FCOE capability, where they'll basically present a single HBA that's 4 gigs and then 3 Flex NICs. So your maximum is 4 Flex NICs, whether you go with fiber channel over Ethernet or the traditional Ethernet model. Another important point here is the G6s have 10 gig links on board, and the G7s, which have just recently been announced along with FlexFabric, they are the first blades that are going to support the CNA onboard. You can still do onboard on traditional G6s or priors, but those are going to be a mezzanine card, and you're going to put those in the mezz card inside that blade, and then you're going to populate bays 3 and 4 for your FlexFabric. So mixing the two of G7s and priors might be a little tricky. You might have to buy 4 switches, or you might want to have, move towards G7 in a separate fabric if you're interested here. So if you need to do the mezz card with the older blades, you're going to be putting the FlexFabrics down because the onboard cards are still going to be there. They're going to be traditional 10 gig or prior. If you're going FCOE with FlexFabric in the G7s, it'd be bays 1 and 2. Next design we're going to talk about a little bit is Cisco UCS. One of the interesting things with Cisco UCS is you see these FlexFabric interconnects. Their switching components of their blade chassis have been removed or decoupled from the actual blade chassis themselves. So you're no longer purchasing switches per blade chassis as you're populating. This is a 6-rack unit design with 8 blades in it, so 8 half-height blades. It's basically half the blades of the HP and also about half the size of 6U versus 10U. So smaller chassis itself, but the really interesting thing is all of the brains of UCS as well as the switching components are all physically separate. So as you scale out a rack of UCS blades, you actually you purchase 2 switches and that's it, and you scale into it. They have 2 different models of the switches. They have a 6120 and a 6140. The difference is 20 ports or 40 ports. It's basically double the height, double the ports. You purchase this, and essentially the Cisco blade chassis itself has these fabric extenders. If you guys are familiar with Cisco, very similar to the 2148s and the 2000 series lines of Nexus that are fabric extensions off the 5Ks. These are basically extender modules that are all managed and operated out of these top-of-rack switches. So it's a really interesting design. Basically, you've got 4 ports here and 4 ports here, totaling 80 gigabits of throughput if you want to populate all. You also have the choice of going with one uplink and focusing more on CPU and I/O going on in the blades. So your scalability is here in the FEXs. You can get up to basically a 2-to-1 oversubscription. Really interesting with the external switches. All the management's here, and as you scale, you're not buying extra switches. Cisco, I didn't talk about the mezz cards of HP. They have pretty much any option you'd want for NICs and mezz cards in the HP world. Cisco's got a few interesting options. They have a traditional 10-gig NIC you can populate in them. I'm not sure why you'd use that. They have this is a more common configuration, which they call the compatibility card. It's essentially a CNA card with QLogic drivers or Emulex drivers and firmware. So you can choose an Emulex or QLogic if you're leveraging those 2 technologies in-house. The really interesting card they have is the virtualization adapter, which is basically pre-SRIOV. I think it's going to be SRIOV ready. I think they'll be able to modify it when SRIOV is finalized. That technology is what they're enabling today. essentially you can virtualize NICs. So this 10 gig card here can present multiple NICs to your ESX host or to a standard traditional server. So instead of having two 10 gig ports, you can have 4 ports or 6 ports or 8 ports. And we'll talk about some of the benefits there when you're starting to leverage quality of service or prioritize traffic. So you can present out of this more NICs, their virtual NICs, down to your ESX host so you can manage traffic patterns if you choose to. And they also support, I'm not recommending this right now, but things like VM direct path of putting a NIC off that driver direct into the VM to give you some additional performance. A lot of limitations in that space. It might be interesting if you have a lot of hefty I/O, but I don't see a lot of people needing to leverage that right now. Quality of service, interesting technology. You'll see a lot of designs with Cisco and UCS and the 1000V talking or recommending leveraging quality of service. I just want to cover quality of service real quick. There's essentially 2 different ways to leverage quality of service. One is priority flow control. Built into CNA cards, they're leveraging PFC. That is one of the things that's a difference between FCOE and traditional fiber channel. Priority flow control, basically you see 8 lanes here. These are different queue buffers, hardware-based queue buffers that have buffers for one type of traffic and a buffer for another type of traffic. So when you apply quality of service, you're basically tagging the traffic, saying this traffic is a quality of service 1, a COS, class of service. This is a class of service 2. This is 3. They're different classes, and then you basically have different queue buffers for them. You can leverage those queue buffers to say, do traffic prioritization. Say, this is more important than this, or this gets this much bandwidth. The interesting thing here is if you saturate the class of service 3, it's going to fill its buffer, but the other buffers still have space for the traffic to continue flowing. So that's how if you've got something like vMotion spike in your link, and let's say that's class of service 6 there, and its buffer's full and it can't get any more through, the rest of the traffic can continue going because it has buffer space to continue passing the traffic through. The other thing you can do with class of service or quality service is bandwidth management. It's not the same as all the bandwidth management options you see out there. You can define tiers in your bandwidth management class, and the interesting thing is, let's say tier 3 down here, LAN traffic, it needs more bandwidth. We're using 3 right now, then we need 4, and then we move up to 5. You can actually choose where to pull that bandwidth from. You're not just saying you get 4, you get 3, you get 2, we're done. You can say, okay, everybody gets 3 initially, but if this guy needs more, instead of just pulling it from everybody, I want HPC traffic to give up a gigabit and give it over to the other guy. So you can get a little bit more granular with leveraging bandwidth traffic management. I don't really see a hefty usage on this, but it's important to know it's there and available. Traffic policies. So first I want to go over the different vSwitch options you have out there in the world. All 3, there's an option to manage this traffic when you're moving towards 10 gig. Standard vSwitch, not a lot of complexity. I'm sure everybody, you're here at VMworld, you've probably seen a standard vSwitch before. Essentially, your options for traffic management in standard vSwitch are outbound traffic shaping. So you can go to a port group, and you can cap your traffic at 3-4 gigabits per second per port group. Let's say that might be your VM kernel for vMotion. You can say, don't allow this to go outbound more than 4 gigabits of throughput. With the distributed vSwitch, you had the option with 4.0 and prior to do traffic shaping for in and outbound. It's important to understand the inbound, it's not fully capable. The inbound traffic shaping is a token process that's occurring at the distributed vSwitch down to the VMs. So it actually cannot handle or manage any inbound traffic management of the actual link itself. But it can provide value when you're talking about something like vMotion, which is inter-cluster communications. They can actually manage that because it's a token process inside. But they said they had inbound traffic shaping. I'm not sure I would completely call it inbound, but within the cluster, you can very easily do traffic shaping inbound. The important feature that I've seen with 4.1 with distributed vSwitch is this network I/O control, which I'll talk about a little bit more detail. But essentially, that allows you to do some traffic prioritization, which I'm a big fan of. And then lastly, you've got an option of putting on top of that distributed vSwitch the Cisco Nexus 1000V. Data center-wide QoS policies, the stuff we touched on a little bit earlier. You can actually define traffic patterns and classifications and prioritize your traffic. Some of the other interesting options with 1000V, I'm a big fan of NetFlow and traffic monitoring and seeing your environment. They fully support NetFlow. There's one other thing I wanted to touch on there. Can't recall that process right now. So data center QoS, NetFlow, and VM level monitoring, VM level management, which is really key. So being able to let your network administrator get in and monitor, span a port, track a port, look at what's going on at a virtual Ethernet port level. So down to the VM, they get visibility back to the network guys. Standard vSwitch, a little bit of a closer look. I'm not going to touch on this too much, but basically we're talking about physical NICs. You've got layer 2 port groups, and you're doing VLAN tags in your port groups to do layer 2 isolation. This is where you would do your traffic shaping in a standard vSwitch. Think you can also traffic shape here, but essentially most of the traffic shaping is occurring at the VM port group level. So go into the vMotion port group and say traffic shape this down to 3 gigs or 4. Distributed vSwitch, not a serious difference between the two other than these new features we're talking about, but the functionality is very similar. So distributed vSwitch, what you're essentially doing is when you create a DVS, one DVS, you define your uplinks. You say, I want 4 uplinks, and it's going to go out to all your ESX hosts and say, I'm going to grab 4 uplinks from each of you and put them into the distributed vSwitch. So you kind of configure it once. In the port group level is where you basically define your VM kernels, define your virtual machine traffic, and do a lot of your management. So you define your uplinks. One thing we've seen a lot is people start to think they might actually need more than one DVS. In the DVS world, essentially, what you would see in a vSwitch, in a standard vSwitch design, is actually an uplink group. So you don't need more than one DVS, you need more than one uplink group. If you want to do physical isolation, going at a different NICs, just create uplink 2 and add more NICs in there, or uplink 3 and add more NICs in there, and then you can associate your virtual port groups with one of those uplinks. So you don't need more than one DVS in all cases I can think of. You just need more uplink groups. So this is an uplink group from 4 different ESX hosts, and this is another uplink group from those same 4 ESX hosts, essentially. Then you've got the Nexus 1000V. This requires the distributed vSwitch option, and then you put on top of it a Cisco design. The first thing involved in 1000V is a virtual supervisor module, very similar to traditional Cisco switches. It's got an IP address. You log into it through CLI, Telnet, and you can administer and manage it very similar to a standard Cisco switch. You install this VSM. They have an appliance, the 1010 physical. You can put it outside the environment. It'll be your supervisor module for those ESX hosts. You can install it on a physical box, on a separate VM ESX cluster, or inside that cluster. And I'll talk about some options in doing that. But this virtual supervisor module can do an active-passive design. You can basically have a secondary for it. And then on top of that, you have a virtual Ethernet module, which these are actually packages deployed down to the ESX host with ESX or ESXi. The VM module can typically be deployed through Update Manager, except with 4.1 right now, a little challenging. But you put the VM modules out on the ESX host, and the physical ports in that actually show up in the VSM when you log in as blade modules. So you'll see blade 3, blade 4, blade 5 with 2 ports or 4 ports, however many are actually in the ESX host themselves. And then on top of those VM modules, when you're managing it, you define the uplinks and you put your VMs inside the port groups. So looks and feels like the standard switch, but it's a Cisco-like OS for you to administer and allows you to let your network administrators manage the network again. This is really the key here when you're talking about 10 gig is what different types of traffic are going over those NICs. A lot of people, VMware themselves, their first document for 10 gig said 10 gig's just fast enough. You can just put your network on there and you're good. Whereas if you start thinking about those traffic patterns, the one that becomes really important here is vMotion. vMotion is not a very critical traffic pattern. If it fails, there's a lot of checksums going on. It's going to retransmit that packet. If you saturate your link, I think we'd all agree we probably don't want to prioritize vMotion over everything else going in the environment. The problem here is vMotions actually, when you kick them off, are one of the fastest traffic patterns you'll see going across that NIC. So not only will they spike the traffic, but you'll actually see the other traffic start to fail or jitter or lower in I.O. capabilities because of vMotion occurring. With 4.0, again, the limitation was at 5.2. I've seen plenty of 10 gig NICs that can't do more than 3.5, 4 gigabits of throughput, and I'll talk about some that can. But the important thing is to understand that you want to prioritize your traffic or shape your traffic to accommodate for that vMotion performance when you kick those off, so you don't have performance impacts. In the old world, we'd have dedicated NICs for vMotion, and we had no impact. We could kick off vMotion, our VMs continue to talk all day long. But now that you're consolidating a fabric, it's important to understand you do need to manage the traffic for vMotion. Other traffic patterns out there, I think it gets a little hard to prioritize. One person brought this up. I look at fault tolerance as very, very critical. I look at Ethernet storage as very critical. And then also management traffic. I didn't identify this as really critical, but the service console, if you lose access to the service console, you're going to have HA host isolation kicking in. So all three of those are really important traffic. I think really just put them all at the highest priority. I don't see a lot of network I.O. other than vMotion occurring in most environments. I don't see you using more than half a gig would be huge. 250 megabits per second would be a busy environment. But really the importance is these links give you benefit of vMotion being faster and other things going on in the data center. But really, prioritizing all three of these at the highest is probably just fine. It's just making sure vMotion is lower in priority. Because vMotion will actually saturate that link. And we did some studies on this. And the thing is, somebody asked this question, why does vMotion impact the other traffic and actually bring it down? Because it should have the same battle going on there. But I think because vMotion's a large packet, large communications, it starts filling those buffers. But we definitely see impact. If you don't manage it, the other traffic will go down and will jitter and actually hang really, really low. I've got a graphic that VMware put together, but it's at like 3 gigs of throughput, which is not realistic. But it'll show the image of what you'll see. Two different approaches to dealing with traffic management. And every scenario in VMware, you've got an option available to you. So two different scenarios I see is traffic shaping and traffic prioritization. Two different things you can do here. So traffic shaping is the idea of carving up your bandwidth. So you've got 10 gig, and you're going to say 2 here, 4 here, 2 here, 2 here. And you can slice it up and say this is how much bandwidth each group gets, The other option is traffic prioritization. I think you get a little bit better utilization of your 10 gig environment with traffic prioritization. You're essentially saying, this is the most important and this is least important and here's in between. Let everybody use the link to its full capability. But if you start to get contention, let's start prioritizing who gets what. I like that because that allows vMotion to completely use that link, get your VMs done faster, so when you're doing maintenance and you don't have downtime, you're not sitting around for 2 hours waiting on all those vMotions to occur in a large environment. This can definitely let you leverage that 10 gig link, but still ensure traffic prioritization so your important I/O is actually not impacted by that type of traffic. How am I doing on time? I need to go faster? Oh, good. Oh, talking too fast apparently this time, so I'll slow it down. Oh, no questions yet. So with vSphere 4.1, I saw 4.1 came out and I started reading up and I'm like, oh crap, I got to change my entire presentation now. So they've released a feature of network I/O control, and I think it's a pretty interesting feature. I've got a graphic on it next. But essentially what you're doing is network I/O control allows you to outbound prioritize your traffic and allows you to basically leverage the share model that you've seen in VMware today with DRS, basically giving one traffic type 100 shares, 50 shares, 50 shares, and then you can give vMotion 10 or 20 or something like that so that everybody can use that 10 gig link, but in case of saturation, the vMotion gets a lower share quantity and therefore they're not going to saturate the link. Another really cool feature with 4.1, one of the things I think about a lot is NIC utilization and where's my traffic going and how am I ensuring better utilization of the NICs. They released a feature called load-based teaming. I haven't got a lot of answers back on asking questions around this stuff, but it's an interesting concept. They're basically going to start monitoring physical NIC load and leveraging those NICs and actually deciding where the traffic goes based on that load. And the cap they put on that, I'll show you on the next slide, is 75% utilization. They look at it and they start managing traffic. So this is an image on network I/O control. And this is a benchmark study on using it and not using it. And here you basically see they've got 3 different traffic types. I'm not sure exactly which ones they are, but they've got 3 different traffic patterns here maintaining about a gig of throughput, which if anybody's got that going on, call me. I'd love to see it. I don't see that much traffic in an environment ever. But they're sitting around a gig. You see the total traffic going on is about 3 gigs of throughput. Then they kick off a vMotion. You see it going close to 10 gig. But look at the other traffic. We're sitting around probably 20 megabits or something in that case. So vMotion spikes the line. This is just standard config, nothing turned on. And all your other traffic drops in throughput and capability here. So you're seeing an impact if you don't do anything with network I/O control disabled or these other options. vMotion will saturate the link and the other traffic will suffer. So I don't know how many of you out there with the Exchange traffic want to see that pop up coming up on all your clients if you're doing a vMotion, but this is what happens if you don't manage the environment at all, don't do anything with 4.1. With network I/O control, your option on the distributed vSwitch with 4.1, you turn this on, you enable these shares when you're looking under the distributed vSwitch options. You prioritize your traffic with share values, fault tolerance, iSCSI, and vMotion. They've got at 50 here, which I would put it a lot lower than that. And basically, fault tolerance, iSCSI, and probably virtual machine traffic is at 75, so they're all higher than vMotion. And you see with it enabled, you see no impact to the traffic whatsoever. You still spike the link the same as you did before, but vMotion ended up getting about 3 to 4 gigs of throughput. So it capped vMotion where it needed to ensure the link didn't saturate itself and the traffic didn't have any impact whatsoever. And I've tested this as well, with much lower I/O patterns than what they've got here. My graphs weren't pretty enough to put in the slide, so I thought this was good enough. But my stuff, I did around 10, 20, 30 megabits, and you can see drastic impact to the traffic. So very important, I think, to enable these features. Yes, sir? Question?
Using this, would you use this with the Nexus, or would you use QoS with the Nexus?
Yeah. So this is actually not an option in the Nexus 1000V. This is only to the distributed vSwitch when you're enabling that feature only. Once you enable Cisco Nexus 1000V, you remove these features and you start to leverage the 1000V QoS capability. So you would move from this to QoS in the 1000V world. So this is specific to the distributed vSwitch. I didn't point that out. Both these features are VDS only. So when you're on 4.1, you need to be Enterprise Plus licensed in order to enable these. There are options for standard vSwitch, so don't panic. You can still do something. These cool features where you can get prioritization are for distributed vSwitch only features. Yes? This doesn't touch Fiber Channel whatsoever. So when you're doing FCOE, very good question, Fiber Channel is already prioritized by default. If you're doing CNA cards in FCOE, let me flip back to the QoS slide since I'm talking fast and got plenty of time here. Fiber Channel is separate. It's a separate link. It's not going over that traffic at all. So that's the traffic going over 10 gig. It's a completely separate isolated port. You know, it's HBA's going into your SAN. You're not touching that. So I'll relate it here, though. If you are using FCO and you've got a converged fabric, it's going over the same pipe. And in that scenario, Fiber Channel over Ethernet is defined as a class of service 3, and it's considered a no-drop queue. So it has its own separate buffer, and the CNA cards and the Fiber Channel over Ethernet technology have intelligence to say, I can't handle any more traffic, pause, don't send anymore. It will not drop a single packet with Fibre Channel. It's a high priority traffic that it will not lose that traffic pattern. So in the traditional Fibre Channel world, you're not going over these links, so there's no option for dealing with that whatsoever. You're just treating that like traditional SAN. This is for the network. Yes? Yep. 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 You're not impacting the other traffic in that scenario. You need to deal with that by adding additional links or... Sure. So, okay. So she's asking about a Fibre Channel world, saturating the SAN links and having high I/O when you're doing backups. The best option you have there, it's not part of this content here, but storage I/O control is a pretty cool option. With 4.1, really VMware is just continuing to develop in these spaces of managing traffic. They've enabled a feature called storage I/O control, which basically you can prioritize a VM to another. It doesn't have anything for if VMs are being backed up, how to prioritize that traffic pattern. You just really need to look at something like the the vStorage API that can actually do intelligent block level, look at block level changes and backing up, not doing full backups of your VMs, that sort of stuff. But you can't, there's nothing in the capabilities right now that I've seen to manage that backup I/O saturating a Fibre Channel link. So best option in the storage world is storage I/O control, where you can prioritize different VMs and say if there's saturation on the LUN, it does a similar thing to the share values essentially. It'll back up the queues that it gives to a VM that's saturating the link if it's a lower priority than the other. So it'll give it less queues on the Fibre Channel link so that it can only send so much traffic to lower the latency on the LUN. So, but that's not going to help you in the backup space. So really just managing that. It's a challenge for everybody. But the best option is the vStorage API and trying to reduce full backups of your VMs and trying to look at block level changes. So this is the next feature in vSphere 4.1, load-based teaming. This is basically looking at, you see this is when you're in the port group option, you're picking your load balance teaming options. You choose route based on physical NIC load. This is looking at when you see 75% utilization on the link, it's going to start moving some of the VMs around. One of the questions I've had, and I couldn't find a white paper out here on this yet. I found one on network I/O control. It's really good, but I'm curious what it's going to move at 75%. But the important thing is it's looking at transmit and receive, looking for when a link reaches 75% utilization for more than 30 seconds, it's going to start moving load around so that it can balance the utilization between the two NICs. So interesting concept, but I'd say research it a little bit more before you fully implement something like that. One of the topics I'm going to talk about in a few minutes is testing everything. I think you really need to validate your environment when you're building them out. Important point here is it's not all just about ESX. We're all talking about 10 gig and what we do on the ESX world, but when you're talking about that data center and you've got storage, you've got switches, you've got blades, you've got 10 gig throughout the environment, you don't just need to think about the ESX host. One of the points I want to make here is if these are blade chassis, you've got 16 blades in here with 2 10 gig ports each, and you've got an uplink coming out of here in the virtual Flex 10 or Cisco I/O. You've got a reduced amount of cables there. Who's monitoring that and ensuring that the traffic leaving here isn't getting saturated? Make sure you're monitoring throughout your environment and thinking about traffic patterns to storage, to other VMs, what's going on in the environment. It's very important to have something monitoring these links. I've seen so many environments in the 1 gig world. Cracks me up. You've got 16 servers doing 1 gig, and you've got a Cisco switch with one 1 gig link going into the core. Saturation? So I really think you need to think about the I/O throughout the environment, not just on the ESX box itself. So Fibre Channel over Ethernet. Might have put this earlier in my slides, I guess. I don't know. Essentially, what's the difference between Fibre Channel over Ethernet and traditional Fibre Channel is the physical medium and a couple different protocols that are occurring at that physical medium stack layer 1 to allow the traffic pattern to go through. So you're basically talking about Fibre Channel, the Fibre Channel payload being put in an FCOE header on Ethernet. The very, very important point here is, if you look at it, it is not iSCSI. This is something I had to grasp when I first started looking at this stuff. iSCSI is a TCP-based protocol. You've got IPs you're communicating. You've got Ethernet, you've got IP, you've got TCP, and then you've got iSCSI sitting on top of that. Fibre Channel Ethernet is a very low-level protocol. It's occurring right above the Ethernet stack, so it's got a little bit less overhead associated with it, and it manages and looks just like Fibre Channel in your environment. So when you're looking at Fibre Channel or Ethernet, the main change between that and traditional Fibre Channel is you've got buffer-to-buffer credits in the Fibre Channel world. We're leveraging that priority flow control in QoS that's enabled by default, doesn't require a lot of administration, but essentially they have a queue dedicated to Fibre Channel to ensure the traffic's going through. And the CNA cards have the intelligence when they're talking FCOE to say, I have room for more traffic or I don't. They're managing it that way with priority flow control. No more buffer-to-buffer credits. That's the only difference. Other than that, it's Fibre Channel writing over a physical Ethernet medium. Do you have a question? Oh, no, just yawning. Sorry. Don't mean to put you to sleep. So when you're looking at FCOE, what are the advantages? If you're a traditional SAN shop, You're reducing the cables. Everybody's worrying about FCOE multi-hop, and when's it going to get multi-hop, and when can I get FCOE on the stand? Where do you have most of your HBA ports? Where do you have most of your fiber ports? They're on the host. I like Fiber Channel Ethernet right now. We've had it in our lab. We've got a couple customers. It's been very stable and reliable for us. It's a simple technology. You're managing this just like Fiber Channel. You've got fabric shortest path first, RCSN, worldwide node names, hard soft zoning. It's managing just like a fabric. The only difference is that physical medium and leveraging priority flow control for the first hop. We're talking about reducing a drastic amount of SAN ports, tons of HBAs, the optics that you're paying for in there. So as you're building out new environments, I recommend checking it out. It's been very reliable for us. You're talking about the host side. We don't need FCOE multi-hop, though it is coming. I don't really see that as the criticality. We're talking about port savings, cost savings, simplification, reduction on those end host devices. Oh, yes? So the CNAs? Sure, she's asking about the cabling type. What is the cabling mechanism for CNA cards? There's 2 different cable types. They call them 30 different things. There is, have you guys seen the Cat6 cables with the molded SFPs on both sides, Molex, Twin-X cables? That is one of the cabling standards for 10 gig for FCOE standards. Basically you need data center bridging based cabling. It has to be certified for DCB. The other option is physical optics with fiber channel. So you can do fiber cabling optics, and then you can do a physical medium that's Cat6 with the SFPs on both sides, Twin-X or Molex, whatever they call them. Early on, I'll get to your question in just one second. Early on, they had challenges of vendor compatibility with those SFP modules. It was complete pain because vendors wanted their own SFP on each side, so you'd have to buy the fiber cable, which was quite a bit more expensive. Those cables are quite a bit lower cost than the fiber optics. They do have a distance limitation of 5 meters right now, which is 15 feet. So you're talking in the rack, and then your uplink to the core would be over fiber optic. So 15 feet, 5 meters right now for the Twin-X SFP cable, Yeah, the copper cable. You can go pretty traditional fiber distance. I'm not sure the distance limitation of fiber optic, but they can go quite a bit further. So inside the rack, I like to leverage those pre-molded SFP cables. They're quite a bit lower cost than fiber going out. Yes, sir? Yep. Yep. Talking about the cable with you can get up to 7 meters now. We were just reading on this as well. They're starting to get a repeater mod, something like a repeater on that cable so they can go a little further distance with the Twin-X cabling to get a little longer distances in there. There's going to be some type, I haven't seen one yet, but there's going to be some type of hardware module that basically repeats a signal to allow you a little bit longer distance. Oh, lower cost as well. Cool. The cables are pretty cheap now, so I really recommend when you guys are looking at 10 gig, even 10 gig, they support these SFP cables. They're much cheaper than fiber cables. Just make sure they're supported and they work, but they're definitely lower cost. This might be even lower. Oh, okay. That's in the same play as the SFP modules that you can buy today. They're just longer distance with those repeaters. Yep. So essentially we're talking about you could put 2 SR optics on both sides and put a fiber cable between them, get pretty long distances. The lower cost option is these Cat6 cables with the pre-molded cabling supporting DCB. They're much lower cost, and then they're starting to extend the distance with these repeater options. So a few general recommendations. These are across everything you're doing in 10 gig or a lot of environments. Read the vendor best practices. I see a lot of people who look at the installer admin guide and they look through there, but there's a ton of best practice documentation out there for looking for environments like I'm doing Exchange on vSphere, what do you see there, or I'm doing 10 gig. Try to look and research the best practices from Cisco, from VMware, from whoever you're working with, and try to read those. They're not the Bible. They don't tell you exactly what to do, but read them and interpret them for your environment. I think it's important to read them, but don't just trust whatever they say. You have to think about it for your environment. Every environment's unique. So highly recommend researching, reading best practices when you're deploying. Enable VMXNet 3 where possible. I can't tell you the amount of environments that I've seen the N1000 driver. Basically, when you build out a VM, it has the most basic driver available for the network because you don't have VM tools and there's compatibility issues. Once you've deployed VM tools, shut down your template, remove the NIC, and add the VMXNet 3 NIC. Gives you reduced CPU load on the ESX host and better performance on the network side. So highly recommend looking at your environment for VMXNet 3. Jumbo frames. I've seen some discussions on jumbo frames with 10 gig. And a lot of people think you can't enable jumbo frames in a 10 gig world. I don't know where they're thinking this, but jumbo frames occur at a VLAN level. You enable jumbo frames on the upstream switch. Everything within the VLAN typically needs to be enabled for jumbo frames, but it's important to note you can enable jumbo frames on 10 gig and not for your VM traffic because you don't have jumbo frames throughout your environment. Essentially, if everybody doesn't know what jumbo frames are, it's a larger payload. You can do 9,000 bytes in a packet versus traditionally it's 1,500 bytes in a single packet. So you get more in one single chunk going across the wire. It benefits when you're doing more of a large sequential workload, which is vMotion. In some cases, your IP storage. I have a question on fault tolerance because I've been pinging out to VMware, and we're not quite sure exactly how that packet looks right now. You might think about it, try it, but I highly recommend you enable fault tolerance for vMotion because it's just large chunks of data going across the wire. So let's make that more efficient and get across the wire quicker by turning on jumbo frames. And then IP storage. There's a study from NetApp out there, if anybody's seen it. It's protocol comparison between NFS, iSCSI, and Fibre Channel. And they show jumbo frames actually impacting performance on iSCSI. Read the doc. Their iometer test load workload is a small random block workload. It's not a typical workload you'll see in an environment. It's not a bad doc. It's great comparison of protocols and looking at things, but you still benefit from enabling jumbo frames and IP storage because you've got various different block patterns going on, and we typically see 10-15% performance gains by enabling jumbo frames. So turn on jumbo frames for the VM kernel on vMotion, IP storage, and I'm not sure on fault tolerance. The question on fault tolerance is, does it just take the traffic coming in and send the same exact traffic pattern across the wire, or are they recapping that in a different payload that's maybe 2 megs or something like that? We're discussing that, so I'm not sure, but definitely research the best practices and see what they're saying about fault tolerance if and when there's a doc on that. I couldn't find one. Test. A lot of people, we get in a rush, customers wanting their projects done right away, and they don't have time for testing or whatever, but I've seen so many environments that they haven't actually gone through and put some workload on your environment. There's tools, iPerf and JPerf for network traffic generators. They're really simple to use. You do basically a client and a server and say generate traffic, and you'll get some traffic going. There's a tool called Iometer for storage I/O generation. It's very easy to use. If you are using it for storage, do a little reading on it. You need to change the offset from 512 to 4K as a minimum for storage traffic, just to make sure it's going to align with the storage vendor. But you can use these tools to generate I/O and then just see how your environment manages. One of the things we've seen is not all 10 gig NICs actually perform 10 gig, and not anywhere close. So if you're building your environment thinking it's for 10 gig, you might want to make sure you can actually do 10 gigs of traffic before you think your traffic's going to go across these links. I won't talk about all the different NICs and how they work out there. You can read Google, search Google for 10 gig NIC performance, but Intel's worked really well for us. We find those, I've saturated 10 gig links all over the place with Intel, absolutely capped them out at 9,237 megabits per second. It's really great performance on those Intel NICs. So verify the throughput of the card and just test your environment. Make sure it's actually working the way you think it is. Generate some traffic. See what's going on out there. And then another recommendation, I don't see it all the time, enable a port fast. Essentially what that does is spanning tree port fast on your upstream switch for the host going into ESX. It just basically brings the port online before spanning tree finishes its checks. You want to do that on all your in-host devices, but we see sometimes ESX hosts don't have port fast enabled. It's a different command on the 5K. I can't remember. It's like spanning tree port edge trunk or something like that, but enable what they term as port fast on your switch ports. Never trust the written documentation. I think you can read it, you can research it, but make sure you're applying it to your environment and you're testing it and you understand what you're doing in your world. Everybody's documentation is good. I appreciate it being out there, but it's not always, it's just another guy writing the docs. Nobody's perfect, so make sure you interpret and understand it for your world. It's not everybody's environment. So, some recommendations around the standard. I'm sorry, did I go too fast? There's a guy behind you. Standard vSwitch, a few recommendations here. It is fairly limited on the options for traffic shaping and management. So one of the things I'm recommending is for vMotion, do an outbound traffic shape on that to cap it, because otherwise you will saturate the link. You can put it at whatever you want, depending upon your traffic. Most of the traffic beyond vMotion is not that much, so you can bring this up to 6 gigs if you want, but limit vMotion outbound. There are no options for limiting it vMotion inbound. So to one host, if you got multiple vMotions going to one host, you could still saturate the link, but at least turn on the outbound traffic shaping option. Under the port group traffic shaping, it's kilobits per second. Just do a little math. I think it's like 1 million or 4 million, but something like that. But basically, do the traffic shaping outbound for vMotion. And then when you're going into the 10 gig world, a lot of people are using IP hash, ether channeling. I think it's great. But when you go to 10 gig, I kind of like pinning port groups to certain NICs so I know where my traffic's going. A lot of people thought you could enable an IP hash and then at the port group prioritize a NIC. It doesn't work. And in 4.1, they've actually started popping up an error. It actually tells you it's not supported. So you cannot do an IP hash and still at a port group level pick which NIC you're going to prioritize your traffic to go out of. So I'm recommending using the default outgoing virtual port ID in a standard vSwitch. And then you can pin your traffic to the NIC so you know where your traffic patterns are going out of those 10 gig links. But you certainly can do either option. But the important point here is when you're using Ether channel, it does not support NIC preference at a port group level. It doesn't work. And you'll get a pop-up in 4.1 now. Because essentially the hash is deciding where the traffic goes, not the port group itself. Distributed vSwitch. So I like the distributed vSwitch option. If you have it, consider, or when you go to 4.1, start leveraging some of these newer features. This is, again, what network I/O control looks like. So when you're in the distributed vSwitch and you see how much traffic you've got available, you can define share values for your traffic out there. For my graphic, one of the things somebody pointed out is maybe you want to bring the management traffic up a little bit because it's the service console, and again, HA isolation response. But the key is not a whole lot of the traffic's busy. vMotion needs to be the lowest priority out there, and you might even drop that to 10. It doesn't stop it from using a link until there's saturation. So you're enabling these shares. You can allow everybody to use the 10 gig link. When you start to reach saturation, the lowest priority shares are going to get less traffic available to them. So definitely turn on network I/O control if you have a distributed vSwitch. And consider leveraging the load-based teaming option as well. I'd say read up on it a little bit more. In the network I/O control best practices, it's in my references. They mention that I/O control does not do inbound traffic shaping. So you might consider, depending upon the importance and what you're doing in your environment, enabling inbound traffic shaping for vMotion and throttling that still a little bit, because you do still have the risk of one host is receiving inbound traffic from 3 hosts and it could still be saturated. So I/O control does not cover that by default. I've been talking to some of the product managers at VMware about could we turn it on for just vMotion, because that is inside the data center. We can manage it with tokens, so we could still use this option for inbound shaping as well. That's currently not there, but I'd like to see that so that we can avoid having to traffic shape even further. But this is in the best practices to consider inbound shaping for vMotion, but it depends on your environment. Cisco Nexus 1000V. I like the Nexus 1000V. You get really good granular visibility down to a VM level when you're doing network troubleshooting. Some of the options that I recommend is it's important to understand a VSM. Rob brought this up to me. Rob Cross, one of the guys I work with. Thanks for all your help with this stuff, too. The VSMs are a control plane. They're not data traffic. So if a VSM goes offline, your traffic is still there. Your VLANs are still configured on those virtual Ethernet modules. They're still up. So a lot of people panic about thinking about the VSM and where it is and how do I troubleshoot that. But the VSM itself is a control plane. It's a management point for configuring that switch. But I still like making that redundant. So you can deploy 2 VSMs. It's really easy. When you deploy the second one and you turn it on for the first time at CLI, it's going to say, is this a primary, secondary, or standalone? You just say secondary reboots, you're done. So it's very, very easy to deploy a second appliance in there and make it a secondary VSM. What that does is if the first one goes offline, it just picks up the traffic for it. Pretty simple to enable. And then enable the anti-affinity rule. So go on DRS and say keep these 2 virtual machines on 2 separate hosts. So that'll just keep them on 2 separate ESX hosts all the time. On the 1000V, you've got the option of VPC and IP hash. Their best practice says leverage this. I kind of am going back and forth between IP hash and MAC pinning here. MAC pinning is that option of standard vSwitch, being able to decide where my traffic goes. I can say pin this port group to this NIC and pin this one to this NIC. The reason why you might consider the IP hash is you have no failover time. That Ether channel or VPC is essentially one point of traffic, and if one NIC fails, the traffic continues flowing. There's no failover convergence going on. It's a little faster failover, but you don't get that granular control over where my traffic is, but you have QoS where you can start prioritizing traffic. So kind of go with either option. The importance is to understand the 2 options and what they do for you. Definitely in 1000V, I like the option of configuring quality of service, stuff we talked about before. A lot of people are overwhelmed by quality of service. It's not that hard, and there are good documents on how to explain this stuff out there. The best one I've seen is NetApp, Cisco, VMware have a secure multi-tenancy doc. You don't have to be all 3 vendors or anything. Just read the doc. It's a couple hundred pages, but you can actually just go right into the class of service stuff and see the exact configuration. It's not that hard to configure. Really good stuff. And that's in my references as well. And really important in the 1000V world, you do need to configure the system VLAN option for traffic that needs to be available during the boot process. So service console, Ethernet storage, those need to be configured as a system VLAN. Just when you're in the port group, it's an option to say system VLAN, and then on the uplink, you need to define the system VLANs. That's also in that doc. What that does is basically say make sure these VLANs are there even before it sees the VSM. So make sure they're available. Yes, sir? It's an add-on to Enterprise Plus. So once you enable Enterprise Plus, there's a license from Cisco. I think it's like $600 per CPU or something like that. It's an add-on. When you buy UCS for a while, I don't know if they're still doing this, they bundled it in with the UCS purchase when you're buying vSphere through them, so it was included, but it is an add-on to the Enterprise Plus license. And then lastly, this is an important point here. 1000V right now does not have a queuing mechanism in it, so you're defining class of service, you're tagging the traffic, but you're not doing anything with that tag until you get to the next upstream device. Yes, sir? I can go show you the doc. We'll pull it up right after. All of you guys come up, I'll show you. But right now in the FAQ for 1000V, and I've tested this as of like a week ago on the latest 1000V, and I still see jitter when I configure class of service. And I can show you the config. If you look at the 1000V config guide, you're defining the class of service tag. You're tagging the traffic, but there's no options for enabling queuing or priority of traffic and bandwidth options. So which is what you're tagging the traffic, but you're not doing anything with it yet until it gets to the next upstream device. Once they get that, that's great. And if they have it now and I don't know it, that's great. Turn it on. The fact is, until it has a queuing mechanism to allow prioritization to actually make a decision on it, you're actually not doing anything until it leaves those two 10-gig links. So in my test, some guys don't like this opinion, but you still see jitter. I can turn on all the classes of service configured just like the secure multi-tenancy guide, and when I start doing a vMotion, I see the traffic start jittering. It tries its best because the next upstream device is going to flush the queue quicker, but I still see traffic jitter. So it's not that big a deal, but you can enable the option of traffic limiting the vMotion port group and what it's doing, or guarantee a little bit of traffic for your VMs and your storage traffic. You can still leverage the whole pipe, still manage it, but you might want a queue or rate limit on 1000V until I see a queue occur at the 1000V level. So the difference is you're tagging the traffic, and until they have the options of doing queuing and say bandwidth 25%, bandwidth 30%, until that option exists in 1000V, you're not doing anything with that tag until it gets to the next upstream device. And until then, you're not managing those two 10-gig links getting saturated, at least not as effective as you could be. So, John, if you're here, I don't know who you are, but tell us. Not right now. The complete 1000V configuration. Yeah, the 1010 is VSM. It doesn't have any hardware queue in it as well. There's no queuing right now in any of the 1000V product line. Go look, read the facts. As soon as it's there, great. As soon as that option's there, turn on the queuing. If you go on a VSM and configure it, there's no option for these technologies to do the queuing or bandwidth prioritization right now. So you're just tagging the traffic. It's still great. You can do QoS throughout the data center. The first place you prioritize is at the 6120 on UCS or at the 5K. The option, I talked to Brad Hedlund a lot about this, and his opinion is TCP handles it just fine, and what happens is that 5K, it still has the class of service defined, so it's flushing the other queues faster than vMotion, and therefore TCP should throttle back vMotion. But I've done my own tests, and I still see jitter going on, and I don't think that's great. When I'm talking about a VM getting traffic jittering, I don't want that. So I still recommend throttling a little bit until these queuing options are available. I mean, do your own tests. That's really the key here, is understand your own traffic patterns. Oh. Did I bump forward? I did. So the next specifics are on rack-mounted servers. Really, what should you do with a rack-mounted server? You've got all three options available, and they all cost differently and have different pricing models, so I'm not telling you have to do one thing or the other. You can traffic shape with VSS, you can traffic shape with VDS, and you can quality of service with 1000V. My recommendation, I like the options of traffic prioritization. So if you got distributed vSwitch, I highly recommend leveraging that. And I'm also a fan of the 1000V to give you that VM-level visibility and also net flow capabilities and quality of service throughout the data center. And I'm really impressed with what I'm seeing with FCOE. If you're using fiber channel and you're building out a net new environment, you might want to consider FCOE. It's not a lot of complexity or change to your environment. You can reduce those cable ports a little bit further. HP FlexFabric. So talked a little bit about FlexFabric. Talking about basically removing the need for buying 8 different switches in the back of your blade chassis on HP, and instead buying one FlexFabric or Flex10. The product came out 3 weeks ago, so I tried to change everything. So consider this FlexFabric here, or Flex10. If you've got FCOE in the environment, you would want to buy the FlexFabric, and if you're just using 10 gig with NFS or iSCSI, you'd use Flex10. The importance is you're able to carve off 4 NICs for one side and 4 NICs for the other, so you can define traffic types. And here's my specific recommendations for this. This is for one environment. It all varies, but look at the traffic flow here, and HP's recommendations are a little different than mine. They give a ton of traffic to VM traffic, and I've done tons of capacity planner assessments, and VM traffic is extremely low in the environment. So 2 gigs is plenty. I think 1 gig is plenty. Look at your environment, but give that bandwidth where you can benefit from it. So I like giving a little bit more bandwidth to vMotion so that it can actually move the VMs around a little quicker if I need that, and give a little bit less to VMnetwork. Just look at it. Look at the traffic. Again, I averaged 1,000 VMs from a bunch of studies, and 0.8 megabits per second was the average across all of them. I think combining all of them, it was like 200 megabits per second or something for 1,000 VMs. So the VM network, you don't need to give it as much, and I think HP's recommendation was like 3 or 4 gigs for that, and I just think that's a little high. Your maximum is 10 gigs between the 4, and so this is 1, 2, 3, and then the HP over here for FlexFabric. Otherwise, it would be 4 NICs here and then 4 NICs here. So you get 4 on one FlexFabric and 4 on the other, and you can bond or traffic shape between the two. So I give a little more to less to vMotion, VM and more to vMotion. So the other thing I've noticed in the environments out there is HP removes the quality of service tag. So if you're talking downstream 1000V, very important to note, they actually drop that quality of service tag, so you can't leverage quality of service of 1000V behind a FlexFabric. They basically take in the packet and they reshape the packet. It's in there. I've got the reference in there. It's FACS on HP Flex10, FlexFabric. Both of those products right now, they drop the quality of service tag. So don't think you can use 1000V and do quality of service throughout the data center behind this. You can do the traffic shaping with FlexFabric and then define quality of service upstream if you want to. The other important I've seen is CDP is on here somewhere. Yeah, right here. HP and Cisco, they aren't really seeming to get along as much lately. I don't know why. But I don't know. I don't get it. But Cisco, I guess, is charging them too much on the license for CDP, so they didn't find it cost-effective to enable that. A couple of our customers were frustrated that they couldn't get that the network port leveling visibility in ESX behind this device. Just be aware of it. I don't think it's a huge deal, but you basically can't go in your ESX configuration and see CDP information as to where you're plugged into your fabric behind this, just because they can't afford the Cisco's charging too much, I guess. I don't know exactly what's going on there, but it does not support CDP at all. Yes, sir. Advantage behind FlexFabric would be the VM port level visibility. So you can still let your administrators get in there and see the VMs all the way down, do port spanning, do NetFlow. All the other features of 1000V are still there. You just cannot do QoS. So I don't really see a huge... if I'm doing FlexFabric, be done with it. Otherwise, go... I don't really combine the two myself. But you could still get the VM level visibility and stuff like that. I think it gets a little hairy between your server guys administering FlexFabric and then the network guys coming in behind on 1000V. I don't like that scenario, but you could do it. You know, they'd say it supports it, but I'm not a fan. And then the other important thing with FlexNICs is they are outbound only like the standard vSwitch. They don't do any inbound shaping. So just if your environment needs inbound shaping, be aware of that. You could leverage the inbound traffic shaping in vSphere, but this is outbound only and not commonly written out there, but it is absolutely outbound only traffic shaping, not inbound. So when you're doing these FlexNICs, this 3.5 is only for the outbound traffic. It could take a whole 10 gigs coming inbound, and there's no traffic shaping of that in the technology here. So UCS recommendations. Leverage quality of service. If you're doing UCS, leverage 1000V and or the Palo adapter. Gentleman might be in the room again, the guy who wrote the secure multi-tenancy guide. Thank you for coming to the last session, if you hear me. The Palo adapter has, you can configure quality of service, and it has hardware queuing capabilities in the card. I've not found a ton of documentation on actually prioritizing traffic and when it happens. But apparently you can do this in the Palo adapter and also the QLogic and Emulex cards. But if you're using UCS, consider getting in there and looking at where you're applying a class of service and also where you're doing the traffic prioritization. The prioritization is when you start deciding bandwidth parameters. Right here in the UCS configuration, you've got your different types of traffic. And right here, the weighting. If you're configuring that weighting, you'll start seeing percentages pop up here. You can actually go in the CLI and do log into NXOS and say show run and look at the quality of service. And you'll see in the CLI on the 6120s, you'll start seeing these percentages popping up. They're identifying saying, this class is going to get X% if bandwidth gets saturated, and that's where it starts getting applied. Going lower in the stack to 1000V when it starts getting queuing, that's great. The other reason for leveraging the Palo adapter is you can give yourself those virtual NICs, and you could define 2 for service console outside of the VSM. Or the other option with Palo is you could give yourself 4 or 6 NICs and actually give them different classes of service. And so those physical NICs have a different class of service being applied now. So I could put vMotion on one, and that's a really nice option. It has a separate queue and separate class of service. So with the Palo adapter, I'm not talking about doing VM direct path, but just leveraging it for more NICs in the ESX side. And I like the option of configuring class of service on those NICs and prioritizing traffic that way. I think that's that there, and that's it. Good, 10 minutes. Any questions? I'm sorry. VM direct path, who needs that much I/O? I don't know if you do, great, good for you, but I don't. I don't see anybody needing that type of I/O. Cisco did a very cool VM benchmark with direct path that allowed them to blow out the numbers, but I don't see it in the real world right now. Yes, sir, did you have another question? I don't blog. I tweet, email me, I got my contact info. I love this stuff, but I'm not a blogger. Appreciate you guys' time. Thank you for coming. If you got more questions, come on up. We can talk. We have tons of E+ blogs. Aaron Delp does a lot of blogging at our company. So thank you, guys. 1 second.